The dynamic system we'll be examining is an oven. It features a fan, heating component, and a sensor. The system is continuous since the state variables change continuously over time. Our input is the desired temperature, and the output is the angular velocity and volumetric flow rate needed to make this temperature happen. Here we have the standard household convection oven. Moving forward, we can see the user input, which includes the input, which is the temperature, and the display feature, which reads the temperature back to the user. On the inside, we can see internal components of the fan and the heating system. This particular oven is a gas. Here we have the block diagram for our system. It starts with the input, which is the temperature desired by the user. This then moves forward and goes into the control element of our system. The control element, in turn, sends back a temperature to the user in the form of the display. Moving forward, the control element goes into our sensor. The sensor then breaks into two parts. The first part is the heating element of the oven, and the second part is the fan that sends the heat around. These portions, the sensor acts in temperature, which is degrees Fahrenheit. The heating portion acts in volumetric flow rate, which is meters cubed per second. And then the fan acts in angular velocity, which is radians per second. The system can then be broken into three separate parts. This is the user input. This is the logic board component of our oven. And finally, we have our oven main body. And that is our block diagram.
The governing equations of motion for the fan and the burner are Q dot equals m dot Cp delta T, where Q dot is the heat flow rate, m dot is the mass flow rate, Cp is the specific heat capacity, and delta T is the desired change in temperature. The second equation is m dot equals rho v dot, where rho is the air density and v dot is the volumetric flow rate. The third equation for the fan is omega 2 over omega 1 equals v dot 2 over v dot 1, because we want the output to be in terms of angular velocity. The final equation for the burner is v1 dot equals v2 dot, because we want the output to be in terms of meters cubed per second.
As for the performance of our dynamic system, the control law at play is proportional control. There are some instances where ovens use PID controllers, but they are very costly, so it's not common. The oven works to maintain an average temperature through the performance metrics peaks. If you look at the graph provided by genuineideas.com, you can see this at play here. And again, you can also tell that our system is continuous.
And here's a summary of the dynamic control process of an oven. Thanks for watching.